Have you ever wondered why deep-sea divers wear those bulky suits? It's not just for style or protection from sea creatures. These suits are designed to withstand the immense pressure of the deep ocean. Or why your ears pop when you're going up a mountain? It's all about pressure. As you ascend, the air pressure outside your body decreases, causing the pressure inside your ears to adjust. Just like you, fluids like water and air can push on things. This push is what we call fluid pressure. It's an invisible force that can have very visible effects. We call this push fluid pressure. It's the reason why a balloon inflates when you blow air into it and why a submarine can dive deep underwater without being crushed. Imagine a huge stack of pillows on top of you. That's like being deep underwater. The deeper you go, the more pillows or water are pressing down on you. The weight of all that water creates pressure and it gets stronger the deeper you go. Now imagine those pillows being taken away one by one. As you go higher, like climbing a mountain, the air pressure decreases. Pressure is all around us and it plays a huge role in our world. From the weather patterns that bring us rain and sunshine to the way airplanes fly, pressure is a fundamental force that shapes our environment and our daily lives. Understanding pressure helps us navigate and appreciate the world in a whole new way. So, what exactly is fluid pressure? Think of it like this. Imagine you're holding a balloon filled with water. The water inside is constantly pushing against the balloon surface. Fluid pressure is the amount of force that fluid pushes with, spread out over a certain area. It's like a gentle squeeze, but it acts in all directions at once. The tighter the squeeze, the higher the pressure becomes. This squeezing force isn't just pushing down, it pushes sideways and even upwards. That's right, fluid pressure doesn't care which way is up, it pushes equally in every direction. Remember that feeling of pressure increasing as you dive deeper in a pool? It's a sensation many of us have experienced, whether in a swimming pool or even in the ocean. As you descend, you might feel your ears popping or a slight discomfort in your chest. This is your body reacting to the changes in pressure. There's a scientific reason for that. It's all about how fluids behave under pressure. When you dive into water, you're entering a world governed by the principles of fluid dynamics. The deeper you go in a fluid, the more of it is piled on top of you. Imagine each layer of water adding its weight to the layers below. This cumulative weight increases the pressure you feel as you go deeper. This means there's more weight pushing down, which creates more pressure. In fact, the pressure increases by about 1 atmosphere for every 10 meters you descend in water. This is why deep-sea divers need special equipment to withstand the immense pressures at great depths. We can even calculate this pressure with a simple equation: P equals P0 plus rho GH. This equation helps us understand and predict the pressure at any given depth. Don't worry, it's not as scary as it looks. Once you understand the science behind it, it becomes much more manageable. Plus, knowing this can help you stay safe while enjoying underwater activities. P is the pressure at a certain depth, which is what divers and scientists are often interested in. P0 is the pressure at the surface, usually the atmospheric pressure we experience every day. Rho is how dense the fluid is, which can vary depending on whether you're in fresh water, salt water, or another liquid. G is the acceleration due to gravity, a constant that affects how pressure builds up in a fluid, and H is how deep you are. The deeper you go, the greater the value of H, and consequently the higher the pressure. So the deeper you dive, bigger H, the higher the pressure, bigger P. This relationship is crucial for divers, engineers, and scientists who work with fluids. Understanding it can help in designing better diving equipment, submarines, and even in predicting weather patterns. Pressure everywhere. But what kind is it? Just like there are different types of soda, there are different ways to talk about pressure. Let's explore a few. First up, we have atmospheric pressure. That's the pressure created by the weight of all the air above us, like a giant blanket of air. Then we have gauge pressure. This measures the pressure difference between a fluid and the surrounding atmospheric pressure. Think of it like comparing the air pressure inside a tire to the air pressure outside. Finally, there's absolute pressure. This one's the total pressure, including both the gauge pressure and the pressure from the atmosphere. It's like adding the pressure inside the tire and the pressure outside together. Measuring pressure tools of the trade. Now that we know about different types of pressure, how do we actually measure it? Well, Scientists have some handy tools for the job. One common tool is the barometer. This clever device measures atmospheric pressure, helping us predict weather patterns. Then there's the manometer. This simple but effective tool uses a U-shaped tube filled with liquid to measure pressure differences. And of course, we can't forget about the pressure gauge. These gauges come in all shapes and sizes and are used to measure pressure in everything from car tires to industrial machines. Pressure in action, from dams to deep-sea exploration. Fluid pressure isn't just a scientific concept, it's all around us, working its magic in countless ways. Take dams, for example. These colossal structures are engineering marvels that harness the power of water pressure to generate electricity. When water is stored in a reservoir behind a dam, it builds up potential energy. This energy is then converted into kinetic energy as the water flows through turbines, spinning them to produce electricity. These massive structures use the power of water pressure to generate electricity. The process is both fascinating and efficient. The higher the dam, the greater the water pressure, and the more energy it can produce. This principle is what makes hydroelectric power one of the most reliable and renewable sources of energy in the world. The higher the dam, the greater the water pressure, and the more energy it can produce. But the wonders of fluid pressure don't stop at the surface. Let's dive into the depths of the ocean for another incredible application. Deep sea exploration is a field that relies heavily on understanding and managing pressure. The deeper you go, the greater the pressure, which can be thousands of times greater than at the surface. Remember those special suits divers wear? These suits are not just for show, they are meticulously designed to withstand the immense pressure found in the ocean depths. Without these suits, divers would be crushed by the weight of the water above them. They're built to withstand the immense pressure found in the ocean depths, allowing us to explore this fascinating and mysterious world. Deep-sea submersibles, too, are engineered to endure these extreme conditions, enabling scientists to study marine life, underwater geology, and even search for shipwrecks. And let's not forget about hydraulic systems. These systems are another brilliant example of fluid pressure at work. They are used in a variety of applications, from lifting heavy machinery to operating the brakes in your car. These systems use fluid pressure to power everything from car brakes to construction equipment. By applying pressure to a small amount of fluid, we can generate a much larger force, making these systems incredibly powerful and efficient. By pushing on a small area of fluid, we can create a large force on a larger area, making these systems incredibly powerful. This principle is used in countless machines and devices, making our lives easier and more efficient. From the dams that light up our cities to the deep-sea suits that allow us to explore the ocean's depth, fluid pressure is a force that shapes our world in remarkable ways. Pressure points to remember. So there you have it, a whirlwind tour of fluid pressure. We've learned that pressure is the force a fluid exerts over a certain area, and it acts equally in all directions. We explored how pressure increases with depth and discovered the different types of pressure we encounter every day. We even met the clever tools used to measure pressure, from barometers to pressure gauges. Finally, we saw how fluid pressure plays a vital role in our world, from generating electricity to exploring the ocean depths. Pressure is a fundamental force of nature, and understanding it helps us appreciate the world around us in a whole new light. Thank you for watching. We hope you enjoyed this deep dive into fluid mechanics. Stay curious and keep exploring. But before you go, let's take a sneak peek at what's coming up next on our channel. We'll be diving into the fascinating world of thermodynamics, where heat, energy, and work come together to explain everything from how your refrigerator keeps your food cool to the power behind jet engines. So if you're ready to unravel more of the mysteries of the physical world, make sure to hit that subscribe button and ring the bell icon to get notified about our next adventure. See you soon, and remember, science is everywhere. All you have to do is look.